All right, so the quiz. Okay, so the quiz, it's now too late to submit. So now that it's too late, I can obviously go over the quiz now. And one thing I want to say about quizzes in general, yes, you have until literally just what, a few minutes ago to submit it. But some of you noticed this. If I get your submission early, I can sometimes give you feedback right away. And if it's not quite right, you have a chance to fix it. Okay. So some of you just submitted the quiz like literally 7 minutes ago or something like that. Obviously, I don't have a chance to look at it yet. Okay, but some of you submitted it, let's say on Friday. I usually turn around within 24 hours, but maybe even faster. Okay, it depends on when I happen to get it. So what I'm trying to say is if you submit it early enough, of course, I don't want you to just do a random job and just throw anything together and submit it. But if you submit it early enough, and if it isn't quite right, and I say try this and try that, or try this other thing, you might have a chance to resubmit it. Okay, so that's an advantage of submitting early. So some of you gave it to me like Friday, I can get it to you by Saturday, or Saturday, I can finish it by Sunday, or Sunday, I can finish it by Monday, and so on. Okay, and some of you even submitted it today, but early enough that I have enough time to look at it and say, okay, you either got the full 5 points or this wasn't quite right, try to fix it, then you have a second chance. But if you literally submit it, just a few minutes before class, then obviously I don't have a chance to look at it. Then you have to accept, whatever it is. Okay, so that's just one advantage of earlier submission is that you'll know right away if you got it right. Then of course I'll say 5 out of 5. But if you didn't get it right, I might give you a suggestion and say try this and whatever. Then you have a chance to resubmit it. Okay, so that's one advantage for submitting quizzes early. And one other thing I want to say about quizzes is, yes, I wanted the quizzes intentionally to be very low pressure. You can help each other out. You can use your book. You can have the whole weekend. Okay, so I grade quizzes much, much more leniently than I would exams. Okay, so I grade exams a little bit harder, but quizzes I try to be much more lenient. Anyway, so that's that. Okay, number 1, limit as x approaches 0 coming from the left. So as I come this way, the y values are up here, and where's here? It's 2. Okay, number 2, limit as x approaches 0 from the right. So if I'm coming from the function on this side, the y values are down here at -2. Okay, so for number 3, it's a two-sided limit. Two-sided means there's not a minus there, there's not a plus there. It's got to be the same number from the left and the right. In other words, the answers to 1 and 2 have to be the same. As you can see, they're not the same, so the two-sided limit does not exist. Or you can just put D and E for does not exist. Okay, but let's say this came out to be 2, this also came out to be 2, then the answer to 3 would also be 2, because the limit coming from the left side and the limit coming from the right side would be the same. But in this particular instance, since you didn't get the same answer coming from the left and the right, the two-sided limit, x approaches 0, does not exist, D and E. And you say, how do I know it's two-sided? Because there's no symbol there, right? There's no plus or minus there, so it does not exist. Number 4, f of 0, right exactly at 0, there's a dot at the origin, so that would be 0. Not a little bit to the left, not a little bit to the right, exactly at 0, the y value is 0. Okay, number 5, find the limit by using algebra. So all you have to do is a little bit of factorization. Notice you cannot plug in right away. And using algebra means you don't make a table like 0.99 or 1.01 or whatever. That's too tedious. A little bit of algebra. The top factors in the x plus 1, x minus 1. And then you can cancel the x minus 1s, right? These cancel out. Then you have the limit as x approaches 1 of x plus 1. Now that you got rid of that x minus 1, you can directly substitute. So you plug in 1 and the answer is 2. So even though the limit is 2, that's not really what this says, because when I plug in 1, it's undefined. But if I plug in a number very close to 1, like 1.0001 or 0.9999, then the answer will be very close to 2. Probably be 1.99 something or 2.001 or something like that. Okay. So that was the quiz. I either already gave you your results, or if you just submitted it like literally within the last hour, I probably didn't get a chance to look at it, but I'll get to it eventually. Okay. All right, so that's that. And now we are on to our one section a day. So we're on to 9.3, which is on derivatives and average rate of change. Don't write that down yet. I'll get to it when we have it. So schedule-wise, we are here, right? Tuesday, October 6th. So we do one section a day, 9.3, 9.4, and so on. So Thursday, expect another quiz, and the quiz will more than likely be 9.3 and 9.4 material. Now you might say, well, it's not fair to give us 9.4 material Thursday and still have it on the quiz. Well, yeah, but don't forget, you get to talk about it. You get to have the whole weekend to work on it. Now, if it was closed book and closed notes and all that, yeah, I could understand that. But since you have the whole weekend to work on it, I think it's fair if I give you, 9.4 stuff. Okay, and looking way ahead, one section a day. Looks like we're looking for Tuesday, October the 27th for the next exam. Okay, and as usual, you would turn in all of this stuff. And this is our longest chapter, obviously. Okay, so on to 9.3 now, and that looks like the material. So here we go. All right, so 9.3, the topic is rates of change. Rates of change and derivatives. Okay, and where am I? Looks like I'm on bottom of 559. Rates of change and derivatives. Now, the derivative is a key concept in calculus. In fact, a lot of the rest of our course is on something called derivatives, okay, which also includes rates of change. All right, so first you need the definition of the average rate of change. Okay, so on the top of 560, average rate of change. Okay, and you can put this on your cheat sheet, on your formula sheet if you wish. Okay, so some of the problems are going to ask for the average rate of change of a function, y equals f of x, from x equals a to x equals b. Okay, and I'll show you that in just a moment. Okay, it'll say, they'll give you a function, find the average rate of change going from two x values. So from 3 to 10, or from 4.5 to 4.7, or whatever. Okay, and here we are. F of b minus f of a divided by b minus a. Okay, it's really just the slope. It's the slope of the line joining the 2 points. Okay, essentially it's y2 minus y1 divided by x2 minus x1 in different clothes, as it were. Okay, so this is like y2 minus y1 divided by x2 minus x1. So if you want to take up average rate of change of slope, you already know this formula. Okay, because they're going to give you two x values. You figure out the y values. That's what f of b and f of a are. So that's like y2 minus y1 divided by x2 minus x1. Okay, so that's average rate of change, okay, of a function, so to speak. Okay, and so hopefully you have enough time for that. And for those of you with the text, it's on 560. Go ahead and put it on your cheat sheet. It's basically just a slope. Okay. In fact, I even put it here, m, right? Remember, m is slope in algebra. F of b minus f of a divided by b minus a. Okay, this is a comma f of a. This is b comma f of b. So if you look at y2 minus y1, it's f of b minus f of a. Divided by x2 minus x1, it's b minus a. Okay, then the other formula you're going to need is a formula for a derivative on page 562. Okay, it's a little bit messy, unfortunately. So derivative. So if you're given a function f of x, you have something called the derivative function. And the way you write it is f with an apostrophe. That's f apostrophe x. The way we say it is f prime of x. So P-R-I-M-E, we say f prime of x rather than f apostrophe x. And if you have to write that down, well, not really, because I'm going to show it to you in my notes in just a second anyway. Okay, so f prime of x, limit h approaches 0. So we've done some limits now. Okay, limit h approaches 0, f of x plus h minus f of x all over h. Okay, so again, f prime of x, f apostrophe x, we say f prime of x. It's called the derivative function. There's a limit, and we've done some limits now. Limit h approaches 0, f of x plus h minus f of x all over h. And that's provided the limit exists. We've already seen some examples where this limit doesn't exist, so it doesn't have to exist. If it does exist, we say the function is differentiable, fancy word. So we don't say derivable, we say differentiable. That's the language that's used. Okay. Now, the book has all these other formulas also. Okay. So they give you that. They also give you that for marginal revenue. You don't need it. It's still derivative. Ultimately, you're still doing a derivative. So when it says velocity, you're doing a derivative. Okay. When it says marginal revenue, you're doing a derivative on the bottom of 563. 563. In fact, they give you a little table of when you can use this derivative thing. Okay. And even on page 565 here, you have something called the slope of the tangent. It's still derivative. So I figured out why give you all these different formulas when you only really need one formula, the formula for the derivative that I showed you. Okay. So what is this weird derivative thing good for? On page 566, here are all, and actually not all the applications, here are some applications for the derivative. Okay. Velocity, instantaneous rate of change, marginal revenue, slope of the tangent line. Okay. So if you hear any of these things, it means derivative. Okay. Now in the book, on the homework, you'll sometimes see find the velocity. Say, oh, what do I do? Derivative. Or you might say instantaneous rate of change. You do the derivative. If it says marginal revenue, derivative. Slope of the tangent line, derivative. Frankly, in this one section, you can almost just say, no matter what they say, you do the derivative. They're not going to throw anything off of this list. Okay. So is it say, do I have to memorize it? Well, I mean, if you want to put it in your cheat sheet, you may, but for this one section, you know that all we're doing is derivative. So if you see some, if you say instantaneous rate of change, what should I do? Derivative. Or say marginal revenue, what should I do? Derivative. All of these mean derivative. Velocity of an object, how fast something is moving, something called instantaneous rate of change. Okay, and that's different from average rate of change, as I'll talk about in a moment. Okay, so way back here we were doing average rate of change, okay, between 2 points. For instantaneous rate of change, it's derivative. Marginal revenue in economics, it's also derivative, and slope of the tangent line. So all of these things means derivative. Okay. All right, so we'll jump right into doing a bunch of these. Okay, so again, I'll try to do as many evens as possible. So on paper, it's 1 to 6, 8, 9, 15 to 18, 35 to 38. I hope your book is the same as mine. I think it might be this time, but we shall see. Okay. Okay, so I was going to start off with number 2, f of x equals 6 minus x squared. Okay, from -1 to 2 and from 1 to 10. Find the average rate of change over the interval. I think this is what you have because I'm looking at my notes from last time and that seems to match. Okay, so how about this? Right now, I'll assume that my book matches your book, and if it isn't, then holler and scream at me. But I believe that they're the same this time for the functions. Okay, so here we go. Okay, so average rate of change again is this. So f of b minus f of a divided by b minus a. That's a smudge there. Sorry, it looks like I'm crossing it out, but it isn't. So average rate of change from x equals a to x equals b. You're basically doing the slope. y2 minus y1 divided by x2 minus x1. Okay. All right, so for number 2 on page 569, to give you the function 6 minus x squared, and part A says to go from -1 to 2, and part B says to go from 1 to 10. Okay, these are the x values. That's like x1 and x2. I have to figure out y1 and y2. So how do I get the y values? I plug in. Okay, so f of -1, put a -1 right there and right there. So it's 6 minus a -1 minus a -1 squared. So 6, that's a double negative. 6 plus 1 minus 1. Because -1 squared is 1. And that just comes out to be 6. Okay, so 1 point is -1. 6. Okay, when they give you this interval, these are the x values. You have to figure out the y value. So when x1 is -1, y1 is 6. How did I get that? By plugging in. Then I do the same thing with 2. So I plug in 2. So f of 2, put a 2 here and 2 here. 6 minus 2 minus 2 squared. So 6 minus 2 minus 4, that comes out to be 0. So I have the point 2, comma 0. Right? So one more time, they tell me to go from -1 to 2. Those are x values, x1, x2. I need to find out y1 and y2 by plugging in. So when I plug in -1, it looks like I came out with 6. And when I plugged in 2, I got 0. So these are my 2 points, -1, 6, 2, 0. Okay. You can throw it into this formula, f of b minus f of a divided by b minus a. But ultimately, it's really just y2 minus y1 divided by x2 minus x1. Okay, so I'm only going to write it as m. Okay, yes, it's average rate of change. Okay, if you want to just write m, that's a lot shorter than average rate of change. Okay, so these are my 2 points. So 0 minus 6, right, divided by 2 minus a -1. So that's -6 divided by 3, or -2. Right, so the language we would say is the average rate of change for this function going from -1 to 2 is -2. Okay. On a grander scale, this is going beyond the Call of Duty, but you went from 0 to 6. So that means you dropped 6 units, right? If you started, sorry, yeah, if I go from 0 minus 6, that's a change of -6, and 2 minus a -1 is 3. So the net change is -2 of the function.
Professor, sorry, do you mind if I take a look at the formula again?
I'm sorry?
Can I take a look at the formula again on the top?
Okay, so f of b minus f of a divided by b minus a. If that confuses you too much, it's really just y2 minus y1 divided by x2 minus x1.
Thank you.
Okay. Sure. Okay, part B, they tell you to go from 1 to 10. So I plug in 1 to get a y value. I plug in 10 to get another y value, and then use the formula for slope. Okay. Yes, it's f of b minus f of a divided by b minus a. It's really y2 minus y1 divided by x2 minus x1. Okay, so if I'm going from 1 to 10, so part B. So I plug in 1 and I plug in 10. So I plug in 1 here and here. So 6 minus 1 minus 1 squared, that's 6 minus 1 minus 1, which is 4. So I have 1 comma 4. So that's x1, y1. Okay, then I plug in 10. 6 minus 10 minus 10 squared. 6 minus 10 minus 10 squared is 100. Okay, so that comes out to be negative 104. So I have 10 comma negative 104. All right, so I just go into my formula for slope. Yes, it says average rate of change. I'm just going to write m because I'm too lazy to keep writing average rate of change. I mean, I even abbreviated here. But if I were limited, I would have write it all out, right? I'd have to write what? A, V, E, R, A, G, E, R, A, T, E, O, F, C, H, A, N, G, E. You can write all of that, or you can just write m, right? So I prefer to just write m. And you may just write m for me on a quiz or test or homework instead of writing average rate of change. Okay, so y2 minus y1, negative 104 minus 4, y2 minus y1, or f of b minus f of a, same thing, divided by b minus a, which is the same as x2 minus x1. Okay, so 10 minus 1. All right, so negative 108 divided by 9, and that comes out to be negative 12. Okay. So that's that.
Professor,
Yes, question?
please explain what do you mean by, what does that number represent, minus 12?
Negative 12. Okay, so that's the average rate of change if I go from 1 to 10. Okay, so when I go from 1 to 10, the function looks like it drops by 108 units. Okay, so the y change was negative 108. The x change was 9. So what's the average per unit? It's negative 108 divided by 9. So on the average, it dropped 12 units, okay, for every change in x. So that'll be the average rate of change. Okay,
Thank you.
all right, you're welcome. Okay, let's see if I can think of an extreme case. I don't know, maybe a 9-year period. A stock went from 4 to dropping to negative 104 in a 9-year period. So what's the average? The drop was on 108 over 9 years. So that's a net drop of 12 per year. Okay, so that's what's happening there. All right, so that was number 2. You try number 1 on your own. Okay, now 3 and 4, they give you a table. So it's actually easier. You don't have to plug anything in. Just look at the table. So for number 4, they tell you to go from 3 to 3.5. Now, if this problem was like that, I have to plug it in and grind it out. But you don't have to. Just read the table. So 3.5, I'm using what? 3, 18 and 3.5, 15 automatically. And then for part B, what do they say? Go from what, 2 to 6? So I'm doing 2, 25 and 6, 38. So it's better. It's a shorter problem than 1 or 2. Okay, so sorry, I can't show you both at the same time, but I'll show you again what I have. So 3 and 3.5, I've got these numbers here, 318, 3.5, 15. Okay, 318, 3.5, 15. Okay, and then part B, let's see, set from 2 to 6. Remember, these are both x values. So 2, 6 is 225 and 638. There's nothing to plug in, just read the table. 225, 638. 225, 638. Okay? All right, so now I'll lose the book temporarily. Go from there. All right, so now I just use the formula for slope. y2 minus y1 divided by x2 minus x1, or f of b minus f of a divided by b minus a. They're the same formula. Okay. All right, so y2 minus y1, 15 minus 18, divided by x2 minus x1, 3.5 minus 3. Okay, you can punch it in your machine. Comes out to be negative 6. See, that's what, negative 3 divided by 0.5, which is negative 6. And then part B, same thing. Folks, this is just slope, and you've already done slope before, and we reviewed it at the beginning of our course, right? So y2 minus y1, 38 minus 25, divided by x2 minus x1, 6 minus 2. Or again, this stuff. This is f of b minus f of a divided by b minus a. Okay, so 38 minus 25 is 13. 6 minus 2 is 4. So 13 over 4. You can leave it like that, or if you want to change it to a decimal, that's okay too. But that's basically it. Okay, so that's number 4. Okay, moving right along. Number 6. Okay, given the function, blah, 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 I'll write it down for you. Find the average rate of change over each of the following pairs of intervals. Okay, so they go 1.9 to 2, 1.99 to 2, 2 to 2.1, 2 to 2.01. Okay, so what I'm going to have to do is plug in all of these numbers. And to save time, I'll just show you my table. I need to plug in 2, obviously. All of these seem to have 2, right? 2, 2, 2, 2. I'm going to plug in 1.9, 1.99, 2.1, and 2.01. What's happening is we're taking the average rate of change for very small time intervals. And we're going to see, do the values seem to approach a number? We're finding a limit, as it were. Okay. And then part C, what do the calculations in part A and B suggest the instantaneous rate of change of f of x at x equals 2 might be? Okay, so I'll come back to that. But let me do A and B right now. I have to lose the book, but I need to plug in all of these numbers. 2, 1.9, 1.99, 2.1, and 2.01. Okay. All right, so here's the function. And then putting it in order again, 1.9, 1.99, 2, 2.01, 2.1. Okay, to save time, I'll just show you what it should be. You can verify these on your calculator yourself. Make sure you get the same numbers as I do, but this is what you get. When you plug in 1.9 here and here, I get 16.31. When I plug in 1.99 here and here, I got that. 2 gives me that. Maybe I can do this even, I can just talk about it. Let's see. 2 squared is 4, right? 3 times 2 is 6. So that's 4 plus 6, which is 10. 10 plus 7 is 17. Okay, so I can sort of do that in my head. I certainly cannot do these in my head. Okay, so if you plug in 2.1 and 2.01, this is what you get. Yeah, you can try it on your own later. But I'm going to give you the concept. All right, so now part A, they tell you to go from 1.9 to 2. So now that I have a table, it's like the previous problem where I use these two. It's like 1.9 comma 16.31 and 2 comma 17. All right, so here we go. y2 minus y1, 17 minus 16.31 divided by x2 minus x1, 2 minus 1.9. Okay, that comes out to be 0.69 divided by 0.1 or 6.9. Okay. Again, if it's just a calculation, I'll go quicker. You can punch it out on your own. I don't want to take up class time for the calculation. But anyway, 6.9. Then they do the same thing for all of these. 1.99 to 2. Notice these are really, really close. So that comes a better approximation of the so-called instantaneous rate of change, which we're going to get to in just a second. Okay, so 1.99 and 2, I use these two. So it's 1.99 comma 16.9301 and 2 comma 17. We're always using 2 comma 17 for these. So here we go. 17 minus 16.9301 divided by 2 minus 1.99. Okay, comes out to be what, 0.0699 divided by 0.01, which is 6.99. Okay, so this one came out to be 6.9. This one came out to be 6.99. That it's almost like a limit coming from the left. Okay, so this average rate of change coming from the left of 2, I got 6.9, 6.99. Okay, now if I were to draw this in a number line, I'm going to come from the right side. 2.1 is to the right of 2. 2.01 is even closer. Okay, so now 2 and 2.1, I'm using these two. Notice I'm always doing 2 comma 17. That's fixed. So 2 comma 17 and 2.1 comma 17.71. So here we go. y2 minus y1. 17.71 minus 17 divided by x2 minus x1. 2.1 minus 2. So that comes out to be 0.71 over 0.1, which is 7.1. And then I come in even tighter from 2 to 2.01. Now I'm using these two. So same thing. So y2 minus y1, 17.0701 minus 17 divided by x2 minus x1, 2.01 minus 2. and that's 0.0701 divided by 0.01, 7.01. So there we go. Okay, so each of these 1, 2, 3, 4 answers is an average rate of change. Okay, do these average rate of change seem to approach any number? So that's the idea behind part C. Oops. Okay, what do the calculations suggest the instantaneous rate of change of f of x is at x equals 2? What might it be? Okay, so right at x equals 2, well, the average rate of change coming from the left was 6.9, 6.99. Coming from the right, I had 7.1 and 7.01. Okay, so it looks like we're getting very close to what nice number? We're getting very close to 7. Okay, so I have here, it appears that the slopes approach 7. So we're going to say that is the instantaneous rate of change. So the instantaneous rate of change is 7. Okay, so what we're doing is finding an average rate of change over smaller and smaller intervals. Okay, so the interval is getting smaller and smaller. And that's now leading us to this concept of derivative. Okay, so what are the applications of instantaneous rate of change? Okay, it's the average rate of change, but you let the interval get smaller and smaller, right? So you're going from 1.9 to 2, 1.99 to 2. If you wanted to get even more accurate, 1.999 to 2, and 1.999999 to 2. And then that's coming from the left. Coming from the right, 2 to 2.1, 2 to 2.01. If you wanted to get even more accurate, 2 to 2.0001, or 2 to 2.00001, you would see that the numbers get really, really close to 7. Okay, so now going on to this concept of derivative. Okay, I already showed it to you in the book. I'm showing to you again that a formal definition of the derivative now. So we write it like this. F prime of x is the way you say it. So I have it here. You can write it down or you can look at the video later. Okay, so F apostrophe of x, F prime of x. You can also write it as y prime, y with an apostrophe means derivative. Okay, now I'm supposed to show you a derivation of why does this weird formula work. Okay, so here's the formula. Okay, I'm going to show you this. You're actually not responsible for this, so you don't have to take notes if you don't want to. Okay, you're not responsible for this, but here's the concept. Okay, here's an x comma f of x. If I move h units to the right, okay, I could go to the left. I'm only showing it to the right, x plus h. So this is x plus h comma f of x plus h. Okay, so if I use the formula here or here, same thing, f of b minus f of a divided by b minus a. So I will take f of x plus h minus f of x, that's the top. That's like y2 minus y1, divided by x2 minus x1 is x plus h minus x. That's like x2 minus x1. Okay, now I can't do anything with the top, but the bottom I can fix it up. X plus h minus x, x's cancel out, so I just have h. Okay. So this is like y2 minus y1 divided by x2 minus x1, the average rate of change. And then for the so-called instantaneous rate of change, that means these 2 points get really, really, really close, like we were doing over here, right? 1.9, 1.999, 2.0, we're getting really, really close to 2. We now know how to say that using calculus. If this point gets really, really close, that's saying h approaches 0. Okay, so I take this expression. In front of it, I sneak in limit h approaches 0. Notice this expression here is the same as that. And that's what we're going to mean now by derivative. Okay, f prime of x is limit h approaches 0 of f of x plus h minus f of x, all divided by h. Okay, now you might say, I didn't understand what you did over here. That's okay. If you don't understand, that's fine. Just be able to use this. Okay, so we're doing limits. This formula for some of the problems doesn't come out nice. Now, fortunately, on Thursday, you'll learn a lot of shortcuts. Okay, but we're not there yet. Okay, you have to do the long cuts now. So today you're doing the long cuts for derivative. Okay, and some of you, if you have some background in calculus, you know the shortcuts already, but for now, we're doing the long cut. F prime of x is this limit. Limit as x approaches 0, f of x plus h minus f of x all over h. And one thing you will notice when we're doing this derivative formula, can I plug in 0 right away? Take a look. You're never going to be able to plug in right away because you'll be dividing by 0, and that's a mathematical no-no. Okay, so what inevitably happens is you have to fiddle with the top and somehow by means of algebra cancel out that h, and then you'll be able to plug in, right? And we've already done some problems involving that. Okay, so I'll show you how to do a lot of those now. Okay, so let's see, 8 and 9 are paired together. So let me show you 8, please. Fortunately for 8, they make it a little bit easier for us. Okay, you're given a function f of x is blah, blah, blah. They're already doing us a favor. They're telling us the derivative is 6x plus 2. Okay, so that's awfully nice of them. So A, instantaneous rate of change, that means derivative. Slope of the tangent to the graph, that means derivative. Okay, so remember that little table I gave you? Yeah, all these things. Velocity, instantaneous rate of change, marginal revenue. And by the way, it says marginal revenue. That can be marginal cost or marginal profit. We'll talk about that later. Marginal anything means derivative. And slope of the tangent, it all means derivative. Okay. Now, they were kind enough to tell us the derivative formula is 6x plus 2. So what do I do for A? I plug in 6 right here. Part B, same thing. So the answer to A and B is the same. But what about C? The point on the graph at x equals 6, there you plug into the original function. They didn't give you the y value. The point on the graph means x comma y, right? So I plug into here. Okay, so let me lose the book now. Give you the highlights. Okay, so here's the function. They're telling you already this is a derivative. Say, how do they get that? Don't worry about it right now. Okay, I'll show you a shortcut on Thursday of how to get that. But otherwise, for now, we have to do this stuff for the rest of the problems. So f prime of 6, that means you don't plug into the original. You plug into this new derivative function. Okay, so that's easy. 6 times 6 plus 2, 36 plus 2 is 38. Okay, and I mentioned part B is going to be the same as part A, so the answer is automatically 38. Okay, because part A said what? Instantaneous rate of change, derivative. B, slope of the tangent line, derivative, so same answer. But for C, C says the point on the graph, you have to go back to the original function. Okay, so 6 goes right there and right there. So that's a little bit harder. So 3 times 6 squared plus 2 times 6 plus 11. And you can punch it in your calculator. 6 squared is 36. So 3 times 36. 2 times 6 is 12. Punch it in a machine. 3 times 36 is 108. So 108 plus 12 plus 11 comes out to be 131. So the point on the graph is 6, comma 131. Okay, so that's how you do that one. Okay, so that's number 8. And 8 and 9 are paired. So I try to show you at least one from each pair, right? So I'll do an even one and you do the odd that's very similar to it. Okay. Okay, so now we have 15 through 18, 35 to 38, calculating derivatives. So this is no fun. Okay, that's doing this now. Okay, so here we go. Okay, 15, 16, 17, and 18. Okay, find the derivative. Once we do that, B, instantaneous rate of change. means the same thing. C, slope of the tangent, same thing. So A, B, and C are all going to have the same answer. Okay, so the only hard part is finding the derivative. Once you have that, B is the same, C is the same. Okay, so 16, f of x is 16x squared minus 4x plus 2 at x equals 1. Okay. Here we go. So it's some heavy duty math, to be honest with you. F prime of x. All right, so by formula, limit h approaches 0. By the way, if you want to put the derivative formula on your cheat sheet, go ahead. Okay, it's limit h approaches 0, f of x plus h minus f of x all over h. Okay, now, I claim the f of x part isn't that hard. You just copy the original, right? The minus f of x. So this part minus parentheses, notice that is the same as that. And it's going to be that way for all these problems. The formula says minus f of x, right? So you just copy the original. There it is, minus parentheses 16x squared minus 4x plus 2. And the bottom is easy. The bottom is always h. The hard part for students is always the f of x plus h. So what is f of x plus h? It means right here, pretend you erase that x, put parentheses x plus h. Erase that x, put parentheses x plus h. So it's going to look like this. 16 parentheses x plus h squared minus 4 parentheses x plus h plus 2. That big mess is f of x plus h. Okay. If I just kind of cover these up, I just replaced the original x. See that 16 blah 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 squared minus 4 blah 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 plus 2. The blah blah blahs are just x plus h. Okay. Now I just have some heavy duty algebra. Okay, so x plus h squared is x squared plus 2xh plus h squared. If I square that, right, x plus h squared, I get that. And distribute minus 4x minus 4h. There's a plus 2. And you know from algebra, right, if you go minus parentheses, you just change every sign. Change that to a minus, that becomes a plus, that becomes a minus. So minus 16x squared plus 4x minus 2. Now I'll distribute to 16. Limit h approaches 0, limit h approaches 0. 16x squared, 16 times 2xh is plus 32xh plus 16h squared. Then I just copied all the rest. Minus 4x minus 4h plus 2 minus 16x squared plus 4x minus 2. So great big mess, but very nicely, a lot of things cancel out. As you can see, I crossed off in red. Let me see if I can show it to you. 16x squared cancels out. Negative 4x plus 4x cancels out. 2 minus 2 cancels out. That happens a lot for these kind of problems. You'll see that theme. So I have that one, and that one. These 1, 2, 3 have one in common. They all have h. So I factor out the h, and then I'm going to be able to cancel the h in the bottom. Okay, that will be a very recurring theme for all these problems. So h parentheses, so if I take out an h, I have 32x plus 16h minus 4. Right? Take an h out, that. Okay, this is h squared, right? So if I take one of the h's out, I still have a 16h, and then minus 4. Okay? And yes, now the h's cancel out. So I have limit as h approaches 0, 32x plus 16h minus 4. And finally, at long last, I can plug in h is equal to 0 right there. Don't plug it in here. Remember, it's for h. Okay, so that means it goes to 0. So I'm left with just 32x minus 4. So that is the derivative formula. So the derivative of this function is this. What's so good about the derivative? All those things on the chart. Velocity, instantaneous rate of change, right? Slope of the tangent line, marginal. Okay, again, don't memorize it. But for this section, if you hear of any of those, you know it means derivative. All right, then they want you to plug in x equals 1. So just plug in 1. 32 times 1 minus 4 is 28. And the answer to part C is automatically 28 also. We already said they're the same thing, right? So, see, this book sure is heavy sometimes. Okay, so I found a derivative function, 32x minus 4, plug in 1, and the answer to B and the answer to C are the same. All right, so same thing for 18. See, we have 15, 16, 17, 18, so I'll do the evens. So P of Q, yeah, don't be confused. F of X and P of Q is the same thing. They're just different letters. So 2Q squared minus 4Q plus 5, and Q is equal to 2. And by the way, this actually has applications later, especially in economics. P will stand for price, and Q will stand for quantity. So the price at a certain quantity. So you have a quantity of a good, of an object, and P quite often stands for price. So instead of F of X, we say P of Q. Okay, so here's the function at Q equals 2. Do the same thing. So again, I'll find a derivative, I plug in, and the answers to B and C are going to be exactly the same. Okay, so let me show you 18 now. So here we are. P of Q is 2Q squared minus 4Q plus 5, and P equals 2. All right, so P prime of Q, that's like F prime of X, it's a derivative. Okay, so the bottom is easy. The bottom is always H. The limit is always easy. Limit H approaches 0. So I guess one nice thing is you say, well, I don't like limits. True, you might not limit, but if you had to do a limit, right? What number would you like to approach? The nicest number in math is 0, right? So I guess that's one consolation for doing this. Okay, minus the original function, right? So just like before, minus P of Q, 2Q squared minus 4Q plus 5, that's the same as the original. The hard part is replacing Q with Q plus H. Okay, so mentally think of erasing that Q, put parentheses, Q plus H. Pretend you erase that Q, put Q plus H. So this is the way it's going to look. Limit as H approaches 0. Great big bracket. 2, instead of Q squared, it's Q plus H squared. Minus 4 parentheses, Q plus H plus 5. Okay, so this is that first part. And then minus the original function. So this is P of Q plus H minus P of Q, if I had to use the language. It's the same as F of X plus H minus F of X, all over H. Okay. Again, mind you, you might say, why don't you just plug in 0 right away? You can't, because you'll be dividing by 0. I need to somehow cancel that H. All right, so here we go. A lot of heavy-duty algebra again. Limit as H approaches 0. 2 times Q plus H squared. You can use the shortcut formula. Q squared plus 2QH plus H squared. Okay, then minus 4Q minus 4H and plus 5. And once again, minus parentheses means change every sign. So minus 2Q squared minus a minus 4Q means plus 4Q, and then minus 5. And once again, distribute the 2. So 2Q squared plus 2 times 2 is 4QH plus 2H squared. And then just copy all the rest of the junk. So minus 4Q minus 4H plus 5. Everything else is the same as here. Minus 2Q squared plus 4Q minus 5. Okay, so a great big mess divided by H. But once again, you're going to get a cancellation. So let's see. 2Q squared minus 2Q squared cancels out. Minus 4Q plus 4Q plus 5 minus 5. So they're all gone. I got that one, and that one. And once again, if you look at that one, and that one, they all have a common factor of h. So you factor out the h parentheses, and then what's left behind. So if I take out an h, right, I have 4q. Take out an h, you still have plus 2h. Take out an h, you have minus 4. And then, once again, h cancels out. So limit h approaches 0, 4q plus 2h minus 4. Now let h be 0, so that drops out, 4q minus 4. This obviously was the hard part. And then part B and C, they told me to plug in 2, p prime of 2. That's very easy. Okay, 4 times 2 minus 4. So 4 times 2 is 8. It was so easy, it looks like I messed up. This is 4, should be. 4 times 2 is 8, right? 8 minus 4 is 4. So the answer to part B is 4, and the answer to part C is also 4. Okay. All right, so that's that. Okay, then we have 35 to 38. What time is it? I think I have time to do those. So I wanted to show you at least all the evens. Okay, so 35 to 38. Go back to the book for that. Let's see, where are we? Missing something here. Oh, anyway. Okay, A, find the slope of the tangent to the graph. Derivative. Find the slope of the tangent at the given point, or you just plug in. Write the equation of the tangent line to the graph. Okay, so I'll show you how to do that. And D, skip part D. Okay, so put down in your notes 35, 6, 7, and 8, skip D as in dog, because it says use a graphing utility. I'm not requiring you to use a graphing utility. So 35 to 38, skip D. (35 to 38), all of these, skip part D. Okay. All right, so 36, f of x equals x squared plus 3x at -1, -2. X squared plus 3x, -1, -2. So first I find the derivative function. F prime of x, limit as h approaches 0, f of x plus h minus f of x all over h. So there's a recurring theme, of course. Okay, the original f of x, that's not that bad. It's minus parentheses x squared plus 3x. F of x plus h, that's the hard part. The h is always easy. You're always dividing by h. So right here, pretend you erase the x, put x plus h squared. And plus 3, erase that x, put an x plus h. So that's what it should look like. Okay, so all of this stuff here is f of x plus h. Maybe I'll write that down for you right now since I didn't put it before. So this mess right here, all of that is my f of x plus h minus f of x all over h. I'm using the formula for derivative. Yeah, this one. And I give it to you in the book also. Put it on your cheat sheet if you wish. Okay, so again, some heavy-duty algebra. X plus h squared, x squared plus 2xh plus h squared, plus 3x plus 3h. Distribute minus x squared minus 3x. X squared cancels out. 3x cancels out. Similar theme. That one, and that one are the only ones left. And what do they all have in common? H. And that h is going to cancel the h in the bottom. Right? That's the way these almost always work. So limit h approaches 0, h parentheses. So take out an h, you have 2x. Take out an h, you still have an h. Take out an h, you have 3. And these cancel out. So limit h approaches 0, 2x plus h plus 3. Now I plug in h is 0, so that becomes 0. So I have 2x plus 3, which is f prime of x. Okay, then, that's the hard part. Easy part, I now know that this is the derivative of 2x plus 3. Continuing over here. If you want the derivative at -1, I just plug in -1. So f prime of -1, 2 times -1 plus 3. 2 times -1 is -2. -2 plus 3 is 1. So the slope of the tangent line is 1. Okay, so if you have a graph, this is the tangent line. It just barely grazes the graph. And now what is the equation of the tangent line? We have to use the point slope form. We did this a while back. Okay, so you're given a point, -1, -2. Okay, so the point is -1, -2, and the slope is 1. Okay, so I use the point slope form, which is y minus y1 equals m times x minus x1. If you want to put this on your cheat sheet again, you may. Okay, we'll get that theme quite a bit. Write the equation of the tangent line. You throw it into y minus y1 equals m times x minus x1. Okay, so y minus a -2 equals m1 times x minus x1, x minus a -1. Okay, so in the formula, m goes here, 1. x1, -1, goes here. y1, -2, goes here. Looks like I got some double negatives. So y plus 2 equals x plus 1. If you multiply by 1, you can just forget about it. Okay. And let's do this. Since we're focusing on the calculus, once you get to this stage in some future problems, I'll let you just stop right there. Okay. So if you want to go all the way, you would -2, y equals x minus 1 to make it look like slope-intercept form, y equals mx plus b. But for now, we were doing so much stuff, blah, 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 all this stuff. Once you get to here, I'll let you stop and say, okay, we know we can do the algebra. We're focusing on the calculus right now, and I'll let you stop right here for problems in general. Okay, then the last one, 38. We've got maybe 10 minutes left. I think I can just barely squeeze it in. Unfortunately, this one's the hardest of all because there's a cube. Okay, f of x equals 5x cubed plus 2 at the point -1, -3. So I do the formula for derivative again. Okay, and then you just plug in the slope and then write the equation of the tangent line to the graph. Okay, 5x cubed plus 2. f of x equals 5x cubed plus 2 at the point -1, -3. So that's the given point. Now we've got to find the slope, which means derivative. Okay, so we now know how the game works. F prime is limit h approaches 0. F of x plus h. Okay, replace x with x plus h. So 5 parentheses x plus h cubed plus 2 minus the original function, 5x cubed plus 2, all over h. Okay, so now I have to take a timeout. And so this box here is sort of like a timeout. The problem is going to continue over here. But I need to figure out x plus h cubed. Okay, so that's very messy. So x plus h cubed, well, you can think of it as x plus h squared times another x plus h, right? So I'll figure out x plus h squared first, and then take that times another x plus h. So x plus h squared, using the shortcut, is this. X squared plus 2xh plus h squared. You could also go x plus h times x plus h and FOIL it out. Okay, so this stuff right here is x plus h squared. And then if I multiply by another x plus h, I have x plus h cubed, right? So now I got to multiply all this out. So it's x squared times that and that, then 2xh times that, and then h squared times that and that. Okay, so here we go. x squared times x, x cubed. X squared times h, x squared h. Okay, I'm finished with x squared. Now it's 2xh times both of them. 2xh times x, 2x squared h. 2xh times h, 2xh squared. Okay, I'm done with that. Now h squared times both of them. H squared times x, xh squared. H squared times h, h cubed. Okay, I have x cubed, h cubed. These two combined, x squared h plus 2x squared h, 3x squared h. And similarly, these two combined, 2x h squared plus x h squared, 3x h squared. Sorry, we can't see that there's an x there. But I got it over here anyway. So anyway, now end of timeout. This great big mess, I'm going to put right here. Okay, so now I know x plus h cubed is all this junk. So there it is. Limit h approaches 0. 5 parentheses x cubed plus 3x squared h plus 3xh squared plus h cubed. And now the rest of it. Plus 2. Again, minus distribute. So minus 5x cubed minus 2. Okay, so all of this again is this. X plus h cubed is that, so I put that over there. Okay, then distribute to 5. Limit h approaches 0. 5 times that, and that. So 5x cubed plus 15x squared h plus 15xh squared plus 5h cubed. And copy all the rest of it. These two cancel. These cancel. So once again, I have that one, and that one. And big surprise, what do they all have in common? H. Factor out the h. Limit h approaches 0. So take out an h here, 15x squared. Take out an h here, 15xh. Take out an h here, 5h squared. Okay, h's cancel out. So I have this thing. Now I plug in h equals 0. So since that has an h, that whole thing is gone. Since that's an h, that whole thing is gone. So I'm left with just 15x squared. Okay. So that was the hard part. Now the easy part, plug in -1. 15 times -1 squared. 15 times 1 is 15. And now the equation of the tangent line. So I now know the slope of the tangent line is 15. The point is -1, -3. That's my x1, y1. So y minus y1, y minus a -3 equals m times x minus x1. And just change the double negatives to positive. So y plus 3 equals 15 times x plus 1. And from what I said for the previous problem, yes, you may now stop. That's it. You don't have to multiply it all out. Just leave your answer like that. Okay. All right, and I believe I've shown you all the evens. So your job is to look at the odds. And if you say, I don't know what to do, look at what we did for the even one and do the associated paired odd one. Okay, so I'm done with that. Let's see. Let me stop the share. Anything in chat? Okay. Okay, Jonathan, thank you again, Jonathan. And I think we got that. Okay, I'm done, folks. So we have 5 minutes maybe. Does anybody have a quick question? Otherwise, we can just stop and we're done. So next time, we'll do the next section. You'll have derivative shortcuts. I'll give you a quiz again on Thursday. But again, you can talk about it. So I would say don't even bother studying for the quiz. You can talk about it for a while, and you got the whole weekend to work on it. So no worries there. Okay, so anybody have a quick question? Otherwise, we're done. Okay, that's about it, folks. So have a good evening. We'll see you next time. All
Bye.
right, bye. Good night, everybody.
Good night.
Thank you.
Thank you.